And we're going to start today by proving the following. We're going to prove the converse of the addition property of equality, which says that if x plus z equals y plus z, then x equals y. And here we are assuming that x, y, and z are elements of the real numbers, because the properties that we have are only for real numbers, of course, and so that's all we can work with. So just like in geometry, you're going to start off with what's given, the if part, and that is that x plus z is equal to y plus z. And we also know that x, y, and z are real numbers, and that's given. Now, algebraically, we know that we can just subtract z from both sides, but we do not have properties of subtraction. We only have properties of addition. And so we have to think about what we could add to both sides, and that would be, of course, to add negative z to both sides. Now, before we can do that, we have to know that, in fact, negative z is an element of the real numbers, of course, and that is because of closure, which means that if you were to take the opposite of a real number, you get a real number, and that is a new property that you probably haven't heard of. Now, when we add negative z to both sides, we're introducing a new variable. So technically, we are adding negative z to the quantity x plus z and to the quantity y plus z. Now that is the addition property of equality. We're trying to prove its converse. I'm just going to abbreviate that. So at this point, I really want to get rid of these two. I want this to have a sum of 0, but I can't do that unless they're right beside each other, so, and also grouped together. So I don't need the commutative property, they're right beside each other. I just need the associative property to associate those two terms together. I could do another parenthesis here, but I'm not going to. Oops. And so that is the associative property of equality. Under addition. And so now I can say that z plus the opposite of z is 0. On both sides. And so that property, saying that a number plus its opposite is 0, is called the additive inverse, because it gets me the identity. So now in step 6, I can say that x plus 0 is x, and y plus 0 is y, which is the additive identity. And this is exactly what I was planning on proving. This is in the conclusion of that converse of addition property of equality. So I can say therefore here, and I can write QED, which stands for quo est demonstratum in Latin. Some people put the box with the X in it. To be honest, I don't know the origins of that, but it's all in your personal style. So that's the first proof.